Hello friends. So, welcome to a lecture series on essential mathematics of machine learning. In the last few lectures, we have seen some of the basic concepts of calculus. We have seen what functions are, how we can define domain range of a function, how can we find differentiation, partial derivatives, limits or continuity of a functions. In this lecture, we will see some of the Python implementation of calculus, that is how we can find differentiation or integration, limit, series expansion etc. using Python. First of all, we will use SymPy. SymPy is a library which is used to do various calculation of calculus with Python. So, it is basically SymPy, SYMPY, SymPy. It is what? It is a library to do calculus with Python. Okay. So, first of all we import this SymPy as suppose SYM. Okay. Now, next we declare variables which we are using. So, suppose we are finding derivative of a single variable function. If you are finding derivative of a single variable function, there is only one variable, say x. So, we say x equal to sim dot symbols, and this is basically x. Okay. We have defined the symbol, it is a declaration of the variables. Now, next we suppose we want to find out first derivative of say sin x. Okay. So, we denote it say derivative of say derivative 1, which is equal to say. So, we use sim dot diff. It is the way to calculate derivative of a function for which we want to calculate a differentiation of sin x. So, sin x is in the simp library. So, we call it like simp dot sin x and with respect to x of course, and then we want to find out the answer. So, we say it is print what? Print derivative 1. So, it is a derivative 1, then we run it simply. So, its derivative is cos x. So, we have find the derivative of this is cos x. Now, suppose you want to find out derivative of some other function. Okay. So, you can add some code here, you can simply control V. Suppose you find out derivative of sin x square for example. So, it is sin x square, fine. So, you can simply run the code, then derivative comes out to be 2x cos x square. So, now suppose you want to define your own function and then you find out the derivative of that function with respect to x. So, how can you do that? And then you can simply, I am simply copying it. Suppose you define your function say func function is equal to say sim dot say sin of x or maybe sin square x and plus say sim dot exponential of say exponential of x square. Okay. And here you can call that function whose derivative you want to find out. It is what? It is func, and when you simply run it, then you get a derivative of this function. So, this is the derivative of this function. So, in this way if you have any function which is of course it should be differentiable, then you can find out derivative of that function using this command. Now, suppose for the same function you want to find out second derivative. Okay. Suppose for same function you want to find out the second derivative. So, how can you do that? For second derivative, the basic command is sim dot diff, okay, and the function whose derivative you want to find out with respect to which variable, and n are the number of times you want to differentiate this function with respect to that variable. So, suppose you want to differentiate this function twice. So, you write here 2 simply and you simply run it. So, this is the second derivative of this function with respect to x. Similarly, if you want to find out third derivative, say, so you can write 3 here and then the third derivative will be this function. Okay. So, now suppose you have functions of 2 or more variables, okay, f x y or f x y z. So, how can you find out partial derivative of f respect to x, y or z, or mixed derivatives, second order derivatives, second order partial derivatives, etc. So, let us see that also. Now, again we will use import SymPy as sym, okay. Then we have declaration of variables. Say we have 3 variables x, y and z, which is equal to sim dot symbols, and which is what x, y and z. Okay. So, variables we have declared. Then you can define the function whose partial derivative you want to calculate. So, then you can define that function. So, suppose that function is, you can denote it by fun function is equal to, say you are defining as x cube, say x cube into say y, okay, plus say y square, anything you can take y square, and then say plus z cube, for example. This function you have defined. Now, suppose you want to find out the partial derivative of this function with respect to x. So, how can you proceed? You can simply write, say this is simply a notation deriv 1 underscore x, which is equal to say simp dot diff, I can write, okay, and this is simply function, which is function is func function with respect to x. So, you write x here, okay, and then which you want to print, you want to print derivative 1 with respect to x. So, print whatever you want to calculate. So, it is derivative 1, fine. So, now if you run it, okay. So, this is underscore x is also there. So, this is the definition actually. So, now if you run it, so this is the partial derivative of this function with respect to x. Similarly, if you want to compute partial derivative of this function with respect to y, for example, so we simply write y here. Okay. So, this is the partial derivative of this function with respect to y, okay, and similarly for z. Now, suppose you want to find out the second order partial derivative of this function with respect to x. So, how can you compute that? So, we can simply copy it again. I am copying this code again, and then so you want to find out second partial derivative. So, I am denoting it by some other notation, say 2 with respect to y, with respect to x, and I want to calculate second partial derivative. So, I can write x 2 times here. So, this will give me second order partial with respect to x. So, this is 6 x y is the second order partial derivative of this function with respect to x. Now, suppose you want to find out second order partial derivative with respect to this function of this function with respect to x and y, that is del square f upon del x del y. So, in this case it is very easy to find, simply you replace one of the x with y. So, I am writing here it is simply a notation x y. So, you can replace this by say y here, and this is a notation which you can put x y here, and if you run it, so you will get second order partial derivative with respect to x y. So, what is the answer? So, this is the answer 3x square, 3 times x square, fine. So, this is how we can compute partial derivative, second order or first order partial derivative or higher order partial derivative with respect to x, y or z. If you want to calculate third order partial derivative, you can write 1 time more x here. Similarly, if you want to calculate third order partial derivative of this function with respect to y, so you write 3 times y, y comma y comma y. Okay. So, in this way we can find out differentiation of a single variable or more than one variable functions. Okay. Now, suppose you want to find out the integration of a function. Integration may be definite or may be indefinite. So, how can you find out integration of a function with respect to x? So, how we can do that? So, we use this simple actually codes which is simp dot integrate, you write function. Okay. So, I am denoting it by simply func, okay, and then variable. So, this is basically for indefinite integral, and for definite how we can write? For definite the code is something like this, simp dot integrate function whatever we have defined, and then variable, then its lower limit first, lower limit, and then upper limit. So, this is how you can easily compute. This is for indefinite integral and this is for definite integral. So, let us take 1-2 example based on this, and then we will move further. So, first of all I am taking some of the things from the previous one. So, first of all I have to define symbol, of course declaration of variable is important. So, I am writing that thing here. So, I have defined that. Now, I can define a function or I can simply integrate. I can simply write integral, okay, integrate is equal to say simp dot integrate, okay, integrate which function, say you are integrating sin x and x of course, and then print whatever you want to find out, that you have to print. So, this is so this is basically the notation which I have used to find out this. So, this is simply this, and then you can if you run it. So, let us see what is the integration, it is minus cos x, we already know this. So, in the same way you can define your own function also, okay, your own function here, and then you can call that function over here and integrate with respect to x. Okay. Now, suppose you want to integrate a function and limits are known to you. So, how you can do that? So, I am copying it over here. Suppose you are integrating sin x, okay. Suppose limits are from 0 to 1, okay. So, lower limit is 0, upper limit is 1, and you are integrating sin x. So, let us see what is the answer. Okay. So, you need one more bracket here. to close it. So, it is 1 minus cos 1. Okay. Suppose you want to integrate say e raised to power minus x, for example, e raised to power minus x from suppose 0 to infinity. So, how you call infinity here? For infinity you simply write simp dot double o. Simp dot double o is a notation for infinity here. Okay. So, 0 to infinity if you want to integrate e raised to minus x, and then what is the answer? So, answer is 1. You can check also. So, in this way you can find out definite integral also. So, by this Python you can directly get obtain indefinite integral, as I have already told you, and definite integral also by assigning lower and upper limit of the function which we have defined. Okay. Now, suppose you want to find out the value of the double integral. So, how you can calculate double integral? So, let us see double integral. Double integral which is definite, of course. Okay, how you can do that? So, of course, these commands will remain same. Okay. Now, in this you are having two variables. So, I am declaring two variables x y over here. Okay. And then suppose you are double integral, say d integral, and I am calling again d integral over here. So, first of all I have to define the double integral. So, suppose double integral is something like e raised to power minus x square minus y square. Okay. And what are the limits for x? Limits for x are suppose from minus infinity to plus infinity. So, it is minus simp dot double o minus plus infinity, and for the limits for y is again from minus infinity to plus infinity. So, that means basically y and say minus simp dot double o and simp dot double o. So, this means double integral of minus infinity to plus infinity, minus infinity to plus infinity, e raised to power minus x square minus y square dx dy. So, this to integrate. So, let us see what is the value now. We have already given the print command. So, the answer is pi. Okay. So, how can you call pi here? For pi you can usually use simp dot pi. Suppose in this example, okay, you want to integrate this from 0 to pi, for example. So, you write simp dot pi. Okay. Then if you run it, so this is the value you will get 1 minus e raised to power minus pi. Okay. So, this is how we can get integral also, whether it is a definite integral or indefinite integral, we can easily find out using this Python, and this library is SymPy. Now, suppose you want to find out some limit of a function. Okay. So, how you can compute limit? So, for limit the command is something like this, it is simp dot limit. Okay. Then function for which limit you want to calculate, then variable, and then point, at which point you want to find out the limit of the function. So, suppose again you will import SymPy as simp. Suppose you define symbol x only, and then you write simp. Suppose you want to calculate limit here, SymPy dot limit. So, I am calling it limit 1, for example, okay, of suppose e raised to power minus x, and when x is tending to 0, for example. So, you write variable here x, and at which point when x is tending to 0. So, of course, its value is 1. So, let us see. Okay, we have to change here also. The print we want to find, print is limit 1. Okay. So, the value is 1. Okay. Similarly, suppose you want to calculate another limit of say e raised to power minus x upon x, for example, when x is tending to say infinity. Okay. So, infinity means sim dot double o, fine. So, when you run it, then you will get 0. So, the limit of limit when x tending to infinity of e raised to power minus x upon x is 0. So, likewise you can compute limit of other functions also. So, the simple command which I told you is you simply write simp limit function for which limit you want to find out with respect to which variable and a point, then this simple command will give you the value of the limit of the function. Okay. Now, suppose you want to find out a series expansion. Okay. So, how can you find out series expansion? So, it is now series expansion. So, how you can proceed for series expansion? The simple command is basically simp dot series, then function, okay. Then so, the what is the command? Command is basically series, for series is simp dot series, then you write the function, then variable x, then initial point say x naught, okay, and then the order up to which you want to find out the series expansion. So, this is the main command basically. So, I am writing here hash, this is simply for your convenience that which command you will use. So, see this is the main command. So, suppose let us take the things from here. So, first of all you import SymPy as simp, then you declare the variables, and then suppose you want expansion of simp dot series of say you want of say simp of cos x of x. So, if you are not writing x naught and n here, so it is understood by default it will take x naught as 0 and n as 6. If you are not writing anything here, then by default it will take x naught as 0 and n as 6. So, let us print this exp. So, this is the expansion. This is the expansion of cos x at x equal to 0 up to order 6. Okay. Now, suppose you want to expand say another function, maybe say you can write here cos square x for example at x naught equal to 1 and say up to order 4. So, suppose I am denoting it by exp 1 for example, then this is the basically the expansion of this expression at x equal to 1 up to order 4. Okay. So, in this way we have seen that if you want to find out derivative of a single variable function or multivariable function, if you want to integrate whether it is a definite or indefinite integral, or you want to find out double integral if limits are constant, limit are fixed, then you can simply compute using this Python using a SymPy library. Okay. Moreover, if you want to find out limit of a function or you want to find out series expansion, then also you can do that. In this lecture we have seen that if you want to implement the basic concepts of calculus in Python, we can use that using SymPy library, and it is very easy, it is very direct. Once declare the variables, define the function, then using SymPy.diff, SymPy.limit, SymPy.integrate, SymPy.series, you can simply find out derivative, integration, series expansion or evaluation of limit of a function. Okay. So, in the next lecture we will see about basic concepts of optimization which is required in machine learning. Thank you.